We are going to get started with our unit on exponent rules, and to get us started today we are first going to look at the rules that we follow when we are multiplying exponents. The first rule we are going to start with is the product of powers. The product of powers rule is when you have exponents that have the same base. The base is the bigger number down below and the exponent is the little number up above. So they have the same base. When you're multiplying exponents that have the same base, you can just add the exponents to simplify this answer. So an example, 7 to the power of 2 times 7 to the power of 3 would equal 2 plus 3 is 5, 7 to the power of 5. A quick explanation for why this rule works would be 7 to the power of 2. I know that this is 7 times 7. 7 to the power of 3 I'm multiplying it by, which is 7 times 7 times 7. So altogether we have 1, 2, 3, 4, 5 7s we're multiplying, or in other words, 7 to the power of 5. So that is why this rule works. When we have the same base, we can just add the exponents when we multiply them. This rule, however, does not apply when we do not have the same base. So in this example here, 2 to the power of 3 times 5 to the power of 3, looking at our bases, we have a base of 2 and a base of 5. So these we cannot combine by adding the exponents. This right here is as simplified as it can be. We just leave it like that. We can't simplify it anymore. We can then use this rule to simplify even longer expressions. So in this example here, 4 times a to the power of third times b times 3 times a to the power of 2 times b to the power of 5, every single one of these terms here is being multiplied. So we can simplify this by combining the terms that are in common to make this not be quite so long. So when we're combining terms, we can only combine the terms that have the same base. Just like here we have the same base of 7 and 7, so we could combine them. Here, when they didn't have the same base, we could not combine them. So we cannot combine the a's and the b's together, but what we could do is combine our a's and our a's together. So if we have a to the power of 3 times a to the power of 2, that would be a to the power of 5. We could also combine our b's. B, we just have here when it's just a b, this is like saying b to the power of 1. We have an invisible 1 there. It's just 1b that we're multiplying. So b to the power of 1 times b to the power of 5 would be b to the power of 6. And then finally we have 4 and 3. Neither of these are variables and neither of them have an exponent. So it's okay that it's not the same number because we don't have an exponent here. So we can just go ahead and multiply these numbers straight up as they are. 4 times 3 is 12. So that means that the final answer is 12 times a to the power of 5 times b to the power of 6. The next multiplication of exponents rule that we will be looking at is the power of a power rule. How this rule works is if we have a number or a variable to an exponent, and then all of this is raised to another exponent, what we can do is multiply these two exponents together, m times n. So an example of this, 7 to the power of 5 to the power of 2 would be equal to, I could simplify this to be 7 to the power of 5 times 2 is 10. Again, a quick explanation for why this works. 7 to the power of 5 to the power of 2, what I'm doing here is 7 to the power of 5 times 7 to the power of 5. I have 2 of them that I'm multiplying. And so I have the same base that when I put them together with multiplication, this would be 7 to the power of 10. So it's essentially adding this exponent this many times. That's why we can multiply them. If we look now at the next level up, 7 to the power of 5 to the power of 3, 5 times 3 is 15, so this would be 7 to the power of 15. And then again, the reason why this rule works is because I have 7 to the power of 5 3 times, and I know that when I multiply exponents that have the same base, I just need to add the exponents. So here I am adding this exponent of 5 3 times to get 15. So essentially I'm doing 5 times 3. So I'm multiplying these two together. And again, this is why this rule works. The final rule that we are going to look at today is the power of a product rule. How this rule works is if you have two variables or numbers that you're multiplying together, and you raise both of them to an exponent, what you can do is individually write each one of these to that exponent. So here's an example of that. X times y all to the power of 4. I could rewrite this as x to the power of 4 times y to the power of 4. An important note that I want to make is that this needs to be multiplication. Like in this example I just wrote here, we have x plus y all to the power of 4. In this case, we cannot use this rule because we are not multiplying. So we cannot simplify this here using the power of a product rule. Here's another slightly more complex example. 3 times a to the power of 2 times b to the power of 5 all to the power of 3. So since on the inside of this parentheses we only have multiplication, that means that this exponent of 3 on the outside needs to be applied to each term here, each variable or number on the inside. So then that would equal 3 to the power of 3. Then we have a to the power of 2 to the power of 3, which in a second here we can use the power of a power rule that we just did on the slide before. Then times b to the power of 5 to the power of 3. So I can simplify this even more. 3 to the power of 3, 3 times 3 is 9, times 3 is 27, times a to the power of 2 times 3, 6, times b to the power of 5 times 3, 15. So this is our simplified version of the original statement. All right, so to end this video, I am going to show you one example of all three of these rules combined together, how we can apply them all at once. So we have this example here, -4 times x times y all to the power of 3 times -2 times x squared all to the power of 3 as well. So we are multiplying these two parentheses together, but also each one of these multiplication terms here is raised to an exponent. So the first thing that we need to do is get rid of this exponent on the outside. So since I have only multiplication on the inside of my parentheses, I can apply this multiplication to everything inside here. So everything is going to be to the power of 3. So I'll have -4 to the power of 3 times x to the power of 3 times y to the power of 3. There's my first parentheses. I'll do the same with the next one. I'll have -2 to the power of 3 times x to the power of 2 to the power of 3. Well, I know that I'm going to be multiplying 2 times 3 here is 6. So x to the power of 6. Then we can simplify this a little bit more. So now we've gotten rid of that exponent on the outside of the parentheses. So now all we have left is we're multiplying these two parentheses together. So we're multiplying everything here is just being multiplied. So now at this point, we can combine the numbers, the x's, and the y's. So we have here -4 to the power of 3. I can simplify this. This means -4 times -4 times -4, positive 16, times -4 is -64. So here we'll have -64 times x to the power of 3, y to the power of 3. Then the next one here, -2 to the power of 3. This is positive 4 times -2 is -8. So -8 times x to the power of 6. Okay, now let's combine the terms in common. So we have -64 times -8. I know it's going to be positive, and to go through that work, you would get positive 512. We can combine the x's. X to the power of 3 times x to the power of 6. We're multiplying with the same base, so we'll add them to get x to the power of 9. And then finally, we don't have any other y's, so there's nothing else to combine. So we'll just write y to the power of 3. And this here is your final simplified answer.